Hello, everyone. I want to pick up where I left off with exponential growth and decay. Hopefully, you were comfortable with what we did last class, which was just reviewing how you know if something's exponential growth and decay and what the graph looks like. So, what I'm going to pick up with today is how we actually use it in real life. So, this is a real life application based day. It should be quick. I want to show you the formula that we use, and I also want to show you some of the delta math questions that you'll be asked so that way you're comfortable with what I'm asking you to do. So this was what we ended with last time, what you see on the screen. These were the notes that went through just explaining if it's growth or decay. Now, in actual real life problems, what you're going to see asked is you're going to have a lot of money questions with this, where you have, like number 5 talks about putting $1,000 into a college fund and then earning interest, 5% interest. If you're earning interest, that's a growth because you're getting money based on the amount of money that you are putting into a bank. The other thing that happens a lot with money is you can lose value. Specifically, what loses value more than anything else is a car. You buy a car for whatever amount of money, and the moment you drive it off the lot, it's going to go down in value. That's called depreciating. So if you see a problem that talks about the value of something depreciates, that means that it's dropping by that percent. So that's a decay. So here's how we actually do these word problem types. We're going to use this equation right here. I have the whole thing circled. I would recommend writing down, maybe pausing this video, getting just a piece of paper or taking a picture on your phone of just this formula, because this is going to be the formula that you're going to reference when you do delta math questions, when you're answering any sort of questions for me. So this is the formula that is used anytime you're trying to figure out how much something grows or decays over a period of time based on its rate of growth or decay. So in this formula, A is going to be your amount after how much time has gone by. Going to be a lot of money questions, population questions. You will see like a population will go up or down by a certain amount. The lowercase a that's right after the equal sign, that is how much you start with. So how much money are you initially investing? How much is the car initially worth? What is the initial population? That's the number that's going to go in front of the parentheses. In the parentheses, you're going to either be adding 1 plus your rate or actually doing 1 minus a rate if it's going down. And this is based on how much is it growing. Are you going up by 5%? Are you dropping by 3%? So you're going to take 1 and you're going to add or subtract that rate. Make sure you're writing your decimals right. So I have a little bit of work off to the side, so this might help as well. If you're writing a 5% growth or a 5% drop, you want to write 5% as 0.05, making sure you have that decimal moved over the right number of spaces so you have the correct percent. You don't want to write 0.5 because that would actually be 50%. So if you were going up by 5%, you would do 1 plus 0.05. If you were going down by 5%, you would write 1 minus 0.05. That's going to give you that, we call it the growth factor or the decay factor. How fast is it growing or how fast is it dropping? So you're going to use this formula over and over and over again. There's going to be questions in delta math that are going to ask you to use this formula. There's also going to be a few questions in delta math that's going to ask you to identify if something's growing or decaying in a word problem or with an equation. So here are a few examples here, and I'll also show you some calculator pieces to help you. So let's say we invested $1,000 in our savings account and we are getting 5% interest. So we're increasing our money, so it is growth. So you're going to add 1 plus 0.05. That again is that whole thing is your growth rate. It's above 1. And then your exponent is actually going to be time. So most problems are annual years. You'll see some problems every now and then. We'll talk about something multiplying every day, every week, every month. So the time interval can change. You're going to go with what the problem says. So in this case, it has an annual means once a year, annual interest, and we want to know how much money you'd have after 6 years. So this is what you would enter in your calculator. So if you have your calculator close by, just to make sure you're comfortable, if you're going to go to just your basic home screen, the nice thing is we really don't need graphs for this. You're just using the calculator, and you can use it on your Chromebook if you need to figure out this amount. So you're going to put your initial amount. You're going to put your parentheses. You can type 1 plus 0.05, or you can just type in 1.05, because you know when you add 0.05 to 1, you get 1.05. And then end your parentheses, hit your exponent button, and then put your years. So after 6 years, you would have $1,340 and just above 9 cents, 9 or 10 cents. When you're doing money problems, you can either round to the nearest penny. A lot of the delta math problems will say to the nearest cent, so that's 2 decimal places. Some problems will ask you to round to the nearest dollar. So if that was the case, you would just say $1,340. For the next one, $500 is your initial amount, so that goes in front of the parentheses. Your interest rate is 3.5. That is 0.035. And you're trying to figure out how much you'll have after 5 years. So again, your calculator will do really all the computation for you. So 500 parentheses, you can type in 1 plus 0.035, or you can just type in 1.035. Close your parentheses, hit your exponent button, and we want to know after 5 years. And it will tell us $593.84. Often with these, you'll catch mistakes if you accidentally type in your percent wrong and you get this crazy number that's nowhere near what you started with. It usually helps you figure out something went wrong. If you're losing value or you're losing an amount of a population, so it's going to use words like depreciate or decline or decay, that's when you want to subtract. So that's going to make that growth value or decay value smaller than 1. So this time we have a $25,000 car, that's your initial amount, and it's dropping, depreciating by 11%. So you're going to subtract 0.11 instead of add it. So that, on my calculator, you have 25,000. Parentheses, you can type in 1 minus 0.11, or you might be able to do that in your head and say, well, I know that's 0.89. And then your exponent button, and it wanted to know how much the car is going to be worth in 6 years. So that's our time for our exponent. In 6 years, sadly, the car is about half of its original value, $12,424.53. You can also have a population decline. So in this case, they usually use the word decline instead of depreciate when you're talking about people or even any type of population. It could be animals. So your initial population is 345,000. We are dropping by 3%. So you can do 1 minus 0.03. The other thing you could do is you could just type in 0.97, because if you're dropping by 3%, that means you would have 97% each year. So you can do a shortcut if you'd like. And it wanted to know the population 10 years after this starts. So 10 years later. Now, anytime you're working with something that can't be partitioned, you can't have part of a person, you can't have part of an animal, you're going to round to the nearest whole number. So you'll notice I didn't put any decimals with my answer here, even though they're on my screen. So after 10 years, I'd be at 254,411 people. So that's how it works with these types of examples. I want to show you what delta math looks like. I was looking into some of the problems that I want to assign. Here's an example of what delta math is going to ask you to do. So they're going to ask you a question like this, where they're going to give you, same idea, initial population, initial amount, and then it's going to tell you how much it grows each year, how much it decays each year. So you're going to use that same formula we just talked about, your initial amount. You're going to do 1 plus, make sure you write this as a decimal, so 1 plus 0.035 for this one, and then your exponent would be the number of years. What they want, and you'll notice this one says to the nearest whole number, make sure you read the directions. If it wants to the nearest penny, for example, and you don't put it to the nearest penny, they won't give you credit for it. So those are the little mistakes that I wanted you to check. There is a help video. If you're working on these and you get stuck or you just need to hear an explanation again, you can watch that. The other thing I'm going to have you do, I don't think it's this one. No, I don't want that one. Find the other one. I liked this type of question. So this type of question, you have to identify, is it growing or is it decaying? And how much is it growing or decaying? So for something like this, you're going to look, just like we did in the last set of problems, you're going to look and see that value that has the x exponent. Is it bigger than 1 or less than 1? So for example, with this one, since it's bigger than 1, we would say that it's growing. So you have a drop-down menu where you get to choose. And then for your increase, it's going to be how much bigger than 1 it is. So this would be a 47.1% increase because it added 0.471 to x, or to 1, 0.471 to 1. So you'd submit that. You're also going to see ones that are going to ask you to identify a decay. Let me see if I can find one for you to help you. Here's one. So this one wants to know if it's a growth or a decay. This time, because it's less than 1, it's going to be a decay. So you're going to have to change your drop-down menu. And then it wants to know how much is it dropping. So now you want to see how much did it go down from 1. So this would be 93%. That's a 7% drop. So your decrease would be 7, and that's what it's looking for. those are going to be the majority of the questions that I'm going to ask you. Is I'm going to ask you about what type is it. I'm going to ask you to do some basic solving ones. We're going to get into some of these more complicated things later, but right now that's what I want you to focus on. Can you identify whether it's growth or decay? Can you write these equations? And then can you use these equations to figure out an amount after a certain time period? These Again, you see a lot in real life problems, a lot of money problems, which are way more fun to think about than maybe how a virus is growing over a certain period of time. But you will see a lot of examples with that. So hopefully that helps. I would make sure you have that formula close by, that a times 1 plus r or 1 minus r, and then your exponent is time. And you should be able to be pretty successful on the Delta Math. Have a calculator close by or in your Chromebook, and you'll be set. If you have any questions, let me know. And then after this video, go ahead on to that Delta Math assignment and get it done. See you guys later.